In this model, we focus on data preparation, the step that ensures data is ready for analysis. First, we select the data, choosing the most relevant attributes and records. Next, we clean the data by fixing errors, filling in missing values, or removing poor quality records. Then we may construct data by creating new attributes or records, such as calculating area from length and width. We also integrate data, combining multiple tables or summarizing information. Finally, we format data so it matches the technical requirements of our tools. Together, these steps transform raw data into reliable, well-structured input for analysis. ETL stands for extraction, transform, and load. So the three keys steps for moving data from source system into a data warehouse. So this is where we will do most of the time the data preparation. So first, we extract data from different systems. At this stage, the data is raw and still in its original format. Next, we transform the data. Here, we clean, standardize, and restructure it. For example, fixing errors, unifying formats, joining records, or creating summaries. Finally, we load the transformed data into the target system. This is done as a full load or an incremental load. Once loaded, the data is ready for reporting, analysis, and business intelligence. In real-world datasets, missing values are very common. In some cases, this is an appropriate reason for a value of the field to be missing. These are called legitimately missing data. In other cases, there is not an appropriate reason for the value of the field to be missing. These are called illegitimately missing data. Some missing values are legitimate. For example, incoming left blank by someone unemployed, or pregnancy data not collected for the male patients. Other missing values are illegitimate, caused by skipped survey questions, study dropouts, or equipment failures. When legitimate missing data occur, we need a strategy. First, we want to try to recover the values from the original source. If that's not possible, options could be include removing records or variables with too many missing values, or we can also fill in missing entries with estimates, or using some algorithms that can handle the incomplete data. These steps help to improve data quality for analysis. Let's see how to do it in MySQL and Excel in our Model 7 practice.
First of all, don't forget to execute the Model 7 data source. And you don't need to do anything, just execute it. And don't forget to select your own database. So make sure that all of the tables are created in your own database. And when you execute it, and don't forget to refresh the database so that you will see a couple of the new tables showing under the list of your own database. And now we can do the practice. Let me create a new SQL file. And the first question is to ask us to check the missing values. We're going to using the IS335 to check the missing value. We were using the treatwheel table. So let's check how to using IS335 to check it. So we first of all select all from the treatwheel, and then we check the first column, which is the ID number, using its non-function. So after we execute it, we can tell that there's no result showing up. So that actually means there is no non-value under the ID number column. But however, we don't know which column has a non-value. So what we need to do is we need to check all of the column to see if any of them has the non-value. So we can using the where condition using the or, right? So we're using where ID number is known or position on automobile is none. So let's execute it, and there's still no result showing up. That actually means none of the ID number and position on automobile has the non-value. So now we have to check all of the columns. So the easier way is we just copy paste the condition and then change the column names for the other column names like this. So we copy paste the column names into our SQL query. And then we executed this again. So you can tell that these are all conditions. Now we can see that there's one result showing up. So actually that means for this specific records, there is one non-value under the miles. And to find out, this is optional, this is not required. To find out what exactly the missing value is, we can try to look at the source of the data to see if we can find the correct value for that missing ones. So we know that this table is talk about the tires, right? And we know like the tires, each car has 4 tires. So we can select the information from the tree wheel to find out the specific ID number, so that specific car, to see like what is the mileage for the other tires. So let's see the result. This is the 4 tires for this specific car. And we can check the miles that for other 3 tiles, the miles are all 5943. So that actually means the missing value for this specific mileage should be also 5943, right? So what we can do is we can using the update function to update this table, update this specific records, and then change it to change this value to 5943. So set this mileage to 5943 using the where condition to make sure that the ID number is this. But it is not enough because the ID number, there are 4 records has the ID number. So we need also to specify the positions on the automobile. So what we need to do is we can add another condition after the where number to make sure that we have specific choose this record. So we're using the position automobile equals to LR. And then we can execute it. And we can check about the data again. So we can see here that the missing value has been updated to 5943. We can do the same thing in the Excel. Let's copy paste the data into the Excel and then create a table to looking for the missing values. And so we can have the tiny table, look at the missing values. And here I'm using something called formula test. So the formula test is to find out the how we calculated how we calculated something in a specific cell. So for example, here we have a count blank in H2. So whatever formula we used in the H2, it will show in I2. So that's how test formula works. And then here we have the using the count blank of C2 to C457 to find out if any values are empty. And now we copy paste everything into the copy paste everything and then create the other three columns, including tree depth and the miles. And then we just need to change the formulas to D2 to D457, and then to E2 to E457, and then to find out if there are missing values. And now we can see that there's one missing value in the miles.
The duplicate records are another common data quality issue. They can occur for several reasons. For example, the simple data entry mistake, system glitch during data collection, merging datasets without proper cleaning, or redundant data storage across the system. Detecting and removing duplicates is an important step to ensure accuracy and consistency in analysis. Here we can demonstrate in MySQL how to identify duplicate records. For example, Blakely Tires has now obtained information for each of the 4 tires from 116 additional automobiles with Blakely brand tires that have been collected through recent state automobile inspection facilities in Texas. The data are suspicious because they should contain records for 116 sets of 4 tires, which will be 456 records. But actually, the data include records for 457 tires. We will therefore look for duplicate records in the data.
Now let's see how to find the duplications in MySQL. So we're gonna using the group by function and then group by count. So let's see. We firstly select all from the treat well and using group by to only group by one column. I just give you an example to have a look. So let's use ID number at first. So we will select ID number. And using count. Okay, as the count. And group by the ID number. So let's execute this at first to see the result. So we can see from the result that there are multiple ID numbers in this table and almost all of them having count of 4. It makes sense because the ID number is the ID of each car and each car have 4 wheels. And that's why each record represents one wheel, and then that's the reason we have 4 counts for each ID number. But there's a 5, so which means there might be a duplicate. So now instead of the ID number, what we want to do is we want to have all of the columns, because when we have all of the columns, you can see here, right? So we have for one same ID number, there are 4 records, and that's why it counts as the 4. And now that actually means this ID number has 4 same rows with the same value. Yeah, so that's the reason for one ID number, there are 4 records. And now we want to see for all of the column. For all of the columns, if they are the records has exactly the same value for all of the columns. And if there is, that means there definitely could be duplication for one records. So what we want to do is we want to have all of columns here. because we want to check if they are exactly the same values for all of the records in multiple. So we want to see if they're same values for all of the columns in multiple records. If there is, which means there might be the duplication. So that's the reason we have all of columns here in a select and with a count. And then we copy paste whatever we select into the group by. That's because you have to make sure that since the count is the aggregation, so when we're using the group by, no matter what columns you put in front of the count, you have to put them into the group by. Right, so we have these columns in select before the count. So that means we have to copy all of these columns into the group by. So now let's execute it. Executed this query and let's see the result. So from the result, we can see most of the records, they have the count as 1. That means there's no duplication, right? They are all unique. However, there is one record has count as 2, which means there is duplications for this specific record because there are 2 records are sharing the exact same value. And thus we can confirm that there is a duplication. However, just by looking at the whole table to find the count value is kind of, a waste of the time. So what actually we can do is, instead of, we can actually give it a filtering using having. Okay, we'll give it a filter using having, and the filter would be we only want to see the count number is more than 1, so that we don't need to check about all the distinct or unique values. So by doing this, we can see there's only 1 record showing up. That's because all other records have the count equals to 1. Only these records have the count more than 1. That actually means this is the only records that have the duplication. And now let's see how to deal with the duplication. So to remove the duplication in the MySQL, normally what we did is we create a new table with the non-duplicated data. And we learned that before, which we will use in a distinct. So distinct actually means all the information we select is all unique, right? So we can use, we used to learn how to use distinct to find the name or find the registration date. But here we can use distinct to find all the unique values. So we can create a table called treatable new, and I have one here. I have to drop it first. Yeah. So I'll create a new table, and then we're gonna select all the information from the treatable table, but we have to make sure that we select the distinct information. So we select all from the treatable. And then when we create a table, we will create a table with a new table name as. As means like how we're gonna create this table. All right, so this is another way how we create table from the existing table. Okay, so we use the distinct all to find all the non-duplicated records from the treatable. So let's execute this query, and then the result was showing like there are totally 4, 5, 6 records. And so right now we can using the count function to check the amount of the records in the old table and the new table. So we can select the count from the treatable to see how many records in the treatable dataset. So there are 457 records, including 1 duplication. And then we can use in the same query to find out the amount of records from the treatable new, and that is 456. So actually that means For the new Treadwell table, the duplicate number has been removed. And to double check, we can run the same query to find the duplication, change the table to the new table, which is the Treadwell new, and we execute it. You can tell there's no result. So that actually means there's no duplication in this Treadwell new table. So this is how we deal with the duplications in MySQL. Duplication in Excel is a little bit complicated. We need to use both count ifs and if to do so. So let me give you an example one by one. All right. So the same thing, I will create the formula text here to show the formula in this cell. And then let me show you how to do this. So first of all, we can check about what does the count if mean. So if I use count if, so remember in the MySQL, I always start by ID number, right? So the same thing, we're gonna start by the ID number. So we want to check if the ID number. We're gonna check if the ID number has the same records, right? So what we'll do is we're using the range and the criteria. So here, the range would be from this one to all the way bottom. Okay, so this is the range. And then the criteria will be A2, which means I want to check how many records are as same as how many like cells under the column A, which is under ID number, has same value as A2, right? So we can tell that the duplication is 5, which means there are 5 rows or the 5 cells under the ID number has the same value, as same as this one. Okay, and then we can actually check the duplications for them all. All right, and this is the one thing we can do. And in this case, don't forget, so we need to make A2 to A458 as the absolute reference. That means, so see, if I keep like the A2, A45, and A2, right? So this is the range, and then this is the reference. And then I can drag it down here, you can see that the range and the criteria are changing, right? So actually, so this is changed from A3 to A459, and then this is changed to A3. So this one we want to change because we want to compare all the values under the ID number to see how many values has the same as it is equals to A14518 is equal to the value of this cell. So the same thing for this one. We want to see like the records that which one under this records in the column A, which one is as same as the A4. But you can tell that for the reference, these are also changed, right? When we drag it down, it's also changed. And we don't want this happened. And in this case, what we need to do is we have to make sure that the A2 to A458. This one is actually absolute reference that no matter how we drag it down, it will not change. So to do so, what we can do is we can add the $sign right here, like this. So to add the $sign, and then it will never change. It will not change, no matter how we drag it. Okay, say let me show you. So it is something like this. So you can tell that right now the A2 to A458 it will never change, and then the only thing changed that is reference. And so this means there are 4 records are sharing the same ID number with this one, which is A4. Okay, so this is how the count if means. like same as what we talk about in a MySQL, we need to find all of them, right? So if we need to find all of this columns, we cannot just use the using the ID number. We have to using someone else, and in this case, we cannot use COUNTIF anymore because the COUNTIF is only for one range and one criteria. So what we do is we need COUNTIF S. So we have to add S here. With S, we can have like multiple. You can tell here. With them, we can use multiple criteria range and criteria, like criteria range and then criteria. So we're using the comma to separate them. And now, see, we can add another criteria, which is the range would be B2 to like B457, right? B458, right? So B2 to B458, and then we add a dollar sign. And we just want to check how many records are sharing the same value for position for B2. Okay, so B2, add this. And then this one actually means we want to check for all of the records showing in this Excel table, how many are sharing the same ID number and the position of automobile with this one. Okay, so with this two. All right, so this is the similar to the duplication, the group by in the MySQL. The logic is the same, and now we can literally drag this down, and then we can tell it's already show us that there are two records sharing the same ID number and the position on automobile at the same time, and then for all the others there's only a one. All right, so this is how we find out the duplication. So we're only using the two columns, and then actually we can add all of them. Yeah, so and then what we can do is we can actually drag this down to all the way bottom. Or what we can do is we can highlight this and then put our mouse here and double click. When we double click, it's automatically showed up our result. And this is the COUNTIF, right? And so we can actually using the COUNTIF to do another thing, which is because as we said before, yes, we can using the group by and using count to find out, all of the number of the duplications, and then looking for which duplication is more than two, right? And in MySQL, we can using having as a filter. In Excel, we can use if as a filter. So we know that this is the value. Well, the result of this function is the value, which is either 1 or 2. So what we can do is we can use if this value is more than 1, then we will return duplicate records. Else, it would be empty, nothing. And you can tell that the first one, since it is more than 1, so it is returned as the duplication. And then we just highlight them, double click the bottom cross, and you can tell that there's only 2 duplicate records that shows duplicate. All other ones are empty, right? And then we can literally just filtering this one. We can sort it, or we can filtering this column to give us all of the duplication records. All right, for example, I can filtering. I can filter this to show only duplicates. Now this is a result, right? Or I can sort it to see. Another thing I can do, I can sort it. Sort from Z to A, because other ones are empty. So I have a duplication.
Structured data refers to the data that are arrayed in a predetermined pattern that makes them easy to manage and search. The most common pattern in which structured data are arrayed as a rectangle, with each row representing an observation or record, and each column representing a variable or field. Unstructured data are databases that are not arranged in a predetermined pattern, and therefore in their raw form cannot be stored in a manner similar to that of a flat file. Semi-structured data does not have the same level of organization as structured data, but it does contain elements that allow for isolation of some elements of the raw data when they are imported. Sometimes we find unstructured elements inside structured data. This happens when the data table is well organized with rows and columns, but the content of the field is unstructured. For example, an address field may contain free text. The column is structured, but its value are not. In this case, find all interest in a specific city or zip code requires complex string operations instead of simple filters. It also creates data validation issues, like inconsistent status names or missing zip codes. To make sense of this kind of the data, we need tools like text analysis or machine learning to extract meaning, topic, or sentiment. In this class, we can split address into structured components such as street, city, state, and zip to improve accuracy and usability by using both MySQL and Excel.
Now let's try to check how to split the one column. We're using this address table. So we can check what this table looks like. So we're using the select all from this table. And we'll execute it, we can see the address column. So this address column, there are 4 parts, including the street address, city, state, and zip code. And then we can use in the substring index in MySQL to try to split. So let's see how we work on it. Okay, so we select we use select from and to create the basic structure, and then including the address on the after the select, and then using substring index. And here the substring index actually means we're trying to split the address using comma and space. So the comma and space is like the delimiter. So we're using comma and space to split this address to 4 parts. So, and then there are 4 parts, including index 1, 2, 3, and 4. And now we can use in a number 1 to select the first part, which is the index number 1. There we can put number 1 as the inside of the structure index, and then create it as the street. And now you can see after we execute it, we can see the street has been successfully picked up. And now we want to select the city. So we can try to use it in the same way because we know that the city is the second part. So let's check if we change the number to number 2 and then execute it. Yeah, you can see the result right here. The results are including not just the city, but also the street in front of it. So which means number 2 here actually means not just the second part. It means the first 2 parts if we're using the command space as the delimiter. So this is not what we want. So actually what we can do is we can using the selected, or we can using the result of this substrate index, and then using another substrate index to select the second part from it, because like the address is the source column, right? And if we change the address, we change the source column to the result of this substrate index, then we can get the city we want. So what we can do is we can highlight this one and we can copy paste the substrate index with the 2 as the index and into the source value. So this is the source, okay? And we are trying to pick up the city from the result we got. And in this case, we will change the index instead of number 1, because number 1 is the street, right? We'll change it to -1, because -1 actually means we will pick up the part from the back. So -1 actually means if we count it from the back, then which part is the first part, and that's actually the city. So using -1, we can pick up the last part of the result we get from the middle substrate index from the address. So this is a nested substring index function. So let's execute it, and we can find out that we successfully pick up the city. And now we can put this into the original query with the street we just picked up. And then we can use the similar knowledge to find out the state and the zip code. This is how we do. And think about yourself to see how we get the state and the zip code, right? So here we're using the -2. Actually, that means the last 2 parts from the address, and then from the last 2 parts include the state and zip code, right? And then the first part of that last 2 part is actually the state. And then at the last, when we're using the zip code, since it's already the last part of the original address column, so we don't need to do a nested substrate index. We can straightly use the address and pick up the last part as the zip code. And now let's see how to do the address splitting in the Excel. So we know that the address is 4 part, right? So we want to change the covered address as a street, and then add 3 more columns here to cover the city, state, and the zip code. So what we need to do is we have to insert the 3 empty columns for state, city, state, and zip code. Yeah, so now we can highlight column DEF. And then what we'll do is we'll right click anywhere and click insert. So this will automatically insert 3 empty columns. And then we will change the column names to the city, state, and zip code. And now we will select the C2 to C7, which are the range of the address, and we'll click Data tab in the ribbon, and in the Data tab group, click Text to Column. And when this comes up, we will select Demulated, because we were using the command space to demulate it, right? So we're gonna choose the demulate, click next, and then select the comma instead of the tab. And then click next. And here we will see this is the preview of what the new columns look like. And we will click each of the columns, and then we will make sure that they are all general. So we can tell that now we have the street, city, state, and the zip code. And now if everything's done, we can click the finish. And then you will see that we have the street, city, state, and the zip code successfully split from the original address to 4 new columns.
Derived data are new attributes or columns in a database that are calculated or generated based on existing attribute from the same record. These attributes do not need to be explicitly stored in the database, but can be computed when needed. For example, we can derive mile per month using life of tile and miles. In the table treat well, using a formula like miles per month equals to miles divided by life of a tire.
Okay, now let's see how to calculate a new column using the existing columns. For example, in the treat well, we can using life of tiles and then the miles to calculate the miles per month of each tile. So it's very simple. We can just input the formula using miles divided by the month, which is life of tile months. Yes, and then we can just using this formula to calculate it. You can see the results showing here, and then we just need to give it a new column name called miles per month. Yeah, and also I don't like those decimals too much, so I will run it up to 2 decimal. So we talk about how to use the round function before. Yeah, so this is how we create a new column by calculating the existing columns. To calculate the miles per month in Excel is literally the same thing as what we did in the MySQL. What we need to do is we just need to create a new column. Then use the miles divided by the months, the life of tile. And then miles here is E2 and life of tiles here is C2. So we can use in the formula test to see the formula of the F2. Let's see how it looks like. Then we can also use the roundup in Excel. So it's as same as how we use it in the MySQL. We're just using the round and then with 2 decimal. Okay, so this is the result of the roundup calculation from miles and life of the tile, which is a month. And then we just need to highlight them and then drag it down. Or what we can do is you see that little cross on the bottom right. So we can do 2 things. The one thing is we can drag it down, or we can do another easier way, which is to move your mouse here at the bottom right and then double click it. So as soon as we double click it, and all of the formula will be shown.
Data integration means combining data from multiple sources into one unified view. This process ensures consistency, improves decision making, and makes reporting more efficient. Integration helps solve problems like duplicates or mismatching formats. and it provides a single version of the truth. When integrated data, organizations gain better insights, create accurate reports, and reduce redundant storage. So now let's learn one of the most important functions in SQL, the join. A join clause is used to combine rows from two or more tables based on a related column between them. To understand how a join works, it's essential to compare the structure between database tables. Typically, the join function is applicable only when two tables in a database share at least one column with a meaningful relationship. This meaningful relationship implies that although the columns may have different names, their data types must be the same and they must carry the same meaning. For example, let's examine the structure of two tables, orders and customers. These two tables have a common column named customer ID, and their data types are identical. Therefore, the join function can be applied to these two tables. In other words, if we want to retrieve information about an order's data from the orders table and a customer name from a customer table, we can use join function to search for information in both tables. And in this case, the customer ID serves as a bridge to match data from both tables. The inner join clause in SQL is used to combine rows from two or more tables based on a related column between them, and it returns only the rows that have matching values in both tables involved in the join operation. Let's back to this example. If we want to retrieve information about an order's date from the orders table and the customer names from a customer table, we can use inner join function to search for information in both tables. The customer ID serves as a bridge to match the data from both tables. The query works from bottom to top as, in the last line, inner join customers on order customer ID equals to customer ID perform the join operation. The on statement is the join condition. It specifies that the join should be performed based on matching customer ID values in both tables. And only those rows where the customer ID in order tables matches the customer IDs in customer table will be included in the result set. And from order inner join customers indicates that you are joining the orders table with the customer table. And from order specify that you are starting with the order table as the primary table for the join. And then for the first line, when we say select these columns, specify the columns you want to retrieve from the joined table. And the order ID selects the order ID columns from the orders table. The customer name selects the custom names from the customer table. And then at the last, order date selects the order date columns from the orders table. And here is the result from the query. So even though the customer ID is not explicitly selected from both tables, all information related to the customer ID of 2 has been selected.
In MySQL, an inner join combines records from two tables based on a common column. And in this example, we try to use inner join to integrate the car models into the treatable join table using the ID number. So we can tell from this image that the treadmill join on left table and the car models on right table, they have a matched column which is called ID number, right? The MySQL will find the matched value in both tables and return the relevant table by matching the values under the ID number. For example, the first one, 80441, there are 4 records in the treadmill, has the ID number 80441, and then there is one records in car model table. So what MySQL will do is it will insert the values from car's model, which is Volkswagen, and then put them into the trade wheel join table. Yeah, so this is how inner join works. So let's see how it works together. Here I'm using select all to return all data from both tables. So when I use inner join, and then I also using the T to represent trade wheel join, and I using the C to represent car models. And in the inner join, you have to have on the matched values or the matched columns from the two tables. And then we're using the T ID number, which is the ID number from the trade wheel join, and C ID number, which is the ID number from the car model, to tell the MySQL that these two are the matched column. And after we run it, we can tell that we have all of the data. See, the Volkswagen from the car model now is matched with the data in the trade wheel join. Yeah, so this is how join works. And however, you can tell that there are two ID numbers inside of this result. So if I don't want to have two, so which means I can specify the columns that I want by selecting the columns. For example, if I only want the model from the car model table other than the ID number, I can change the query, like instead of select all, I will select all values from the trade wheel join table, and then only select the model from car model table. Okay, so by doing this, the ID number will not show in the result. We will use XLOOKUP function in Excel to achieve the data integration. So we first copy the trade wheel join and the car model data into two different sheets of Excel data and name them data and model. And then we created a new column called model, and then we, in the F2, we will enter the formula for the XLOOKUP. So the first XLOOKUP is A2. So the A2 is the cell that contains the value to be matched. And then we will go to the model sheet and then click A2 to A115, which identifies the cells that will be searched for the match value. And then we will insert model B2 to B115, which identifies the cells that contains the values to be transferred if a match is found. So literally here, A2 to A115 from the data model, and then A2 to A15 from the model, the car model table. So they are used as the matched columns in MySQL inner join. Okay, and then model B to B15. So that is actually the value we're looking for, which is the car model. So that is the column from like we will select, all right, in the MySQL. So that's the logic of X lookup. And then don't forget to change the A2 to A15 and then B2 to 15 to absolute reference by adding the $sign.